This video is brought to you by Sporlan, quality, integrity, and tradition.
Well, we've got a kitchen AC that is not working. Thermostat should be calling right now, and we have no cooling going on. So let's go ahead and start by opening up the electrical section, having a look at whether or not we truly have a call for the thermostat up here, and see what's going on. Let's go ahead and start with the disconnect switch. Coming out of the disconnect, we've got 204 volts, line 1 to 2. Line 2 to 3, 204 volts, and then line 1 to 3, 204 volts. So we have three-phase power coming out of the disconnect, going into the unit, okay? We come over here, and we open this guy up, and my contactor's pulled in. Look at that. But nothing's running. Contactor's pulled in. I think the indoor blower motor's running. Let's test to see if we have three-phase power coming out of that contactor. So in this particular contactor, they're using a 2-pole contactor, even though this unit is, I presume, a 3-phase because it has a 3-phase disconnect. So incoming power is actually coming into the bottom right here, and obviously 203 from line 1 to 2. But let's look across these guys right here. 203 going through the contactor, nothing across. Nothing across. So we have 203 going through the contactor. Let's go over and open up the compressor section and have a look in there. I'm intrigued though because the condenser fan motor is not running either. The indoor blower motor is running. I pulled the plug off the compressor. We're going to test it. That compressor is really warm, so we're going to check continuity across it and then voltage at the, and it is a 3-phase compressor. Let me put this back on and we'll check that guy out. All right, no matter how I manipulate this Molex plug, I am not getting proper power on the Molex plug. I can't get 3-phase. I can only get 2 legs of power. There's that one, and let's see if I can do it like here. See, I won't get it right there, but I can get it. If I can move it around, I can get it right there, but I cannot for the life of me get leg to leg power on these 2 terminals. It's like the Molex is messed up. The compressor also has no resistance across the windings. It could be overheating, but I suspect there's more going on here because condenser fan motor is not running. Condenser fan motor should be running when the compressor has a call, and it's not. So I suspect that there's a problem with the condenser fan motor. Let's see if it's locked up. No, it doesn't seem locked up. Interesting. I'm gonna have to dig into that a little bit because that should be running right now. I shut the power off and open this up in here, and we've got some weird stuff going on here. So 3-phase power going to the Molex plug is through these big guys. Look like someone changed the Molex plug at one point. But right away, this yellow wire is just sitting here looking like it belongs somewhere. And there's only 2 yellow wires on that capacitor. One of them is going to where? Oh, that's going up. So one of the yellow wires is for the condenser fan motor. It's the common. The other yellow wire is going to a leg in the Molex plug. They're using that capacitor as a jumper back there, and this yellow wire that I found undone is the other leg of power for the 3-phase compressor. So they've been single phasing this compressor for a very long time, and that's why that condenser fan motor is not running. They're going to be very lucky if this compressor actually resets the thermal overload. It's been sitting there single phasing for a very long time. It's probably bad, but it is red hot right now. So we'll let it cool off, and I'm going to go ahead and check that capacitor and then plug that wire back into the capacitor. The capacitor tested okay, not amazing, but I went ahead and connected those wires back to it. So I'm letting this compressor cool off, but if I turn this unit back on and we get a call for cooling, the condenser fan motor should run now, which would make more sense because I was really confused why it wasn't running in the first place. Oh, there we go. Condenser fan motor's turning on. Moving like it's supposed to be. That's a good sign. Now we're just got to cool this compressor off. which is going to be a challenge because I don't want to, I got to make sure that we're not going to, if I cool the compressor off with water, that it's not going to fill the unit up with water. This one uses that silly plastic drain pan. I got to be careful here. Just letting it sit for a few minutes and it reset. So let's make sure all the legs are reset. We're using continuity. There's that one. And then we'll do the last one. Right over here. Yep, all 3 legs have reset. So we can go ahead and turn this guy off, connect the Molex plug, and see if the compressor starts up, and then proceed from there. There we go. Start it up. 12 amps. And dropping. It's slowly dropping. It's under a load right now. Okay. So we know the compressor runs. I'm going to go ahead and head downstairs and get some job link probes so we can probe up on this guy and test the refrigeration circuit. All right, I went down to get my probes and I come up and we're frosting all the way back to the compressor. What's going on here? That's odd. Indoor blower motor's still running. Pulling some serious air. Okay, what we're going to do is shut this guy down for a minute. We know that it runs. First off, before we apply service gauges, these guys are notorious for having leaks. So we want to leak check these guys to see if they're leaking out of the caps before we apply service gauges. Next, there's no insulation on that suction line. That's really smart. So it's just sitting there baking in the heat. So I'm going to do a leak search first, investigate the air filter, make sure we don't have a plugged up return, and then probe up and then evaluate it from there. So far, I get no leaks with the caps on. So that's a good sign. These things are notorious because they have high flow Schraders in them, and you can usually tell. Yeah, see, that one has oil in there, so I bet you it's slightly leaking, but we don't know for sure. I'll get this other one off if I can. This thing's a pain. Gosh darn it, that was hard. And yeah, see, that one's a little shiny inside too. Now let's see if they're leaking. These things always leak. Yeah, it's going crazy. Both of them. Both of them. See, you can see the tips lighting up like crazy. So I think that these things are leaking. So it's good to know that before, because if I apply service gauges and then find out if it's low on charge, then we know that more than likely it's the high flow Schraders. Even though it wasn't leaking out of here right now, the fact that there's oil in there and the fact that they're going crazy with the leak detector indicates that those are a potential problem. So now I'm going to probe up, put all my job link probes on it, and look at the filter and figure out what's going on, if it's low on charge or what. I went ahead and pulled the economizer out real quick. It was bypassed anyways already, but it wasn't closed. But look at how they do their filter. Like, it's just kind of like, yeah, I guess it kind of protects something, not the whole coil that's really dirty, not over here that's really dirty. These maintenance companies are a joke. And there's nothing even holding the filter in place. It's just sitting up there. That's ridiculous. So that evaporator is dirty, but it's not plugged. Like, I'll brush it off a little bit. Look down here. Don't see anything crazy down in there. I know it's hard for you guys to see, but nothing too crazy. Okay, it has been running for a few minutes. It's not frosting back like it was. I didn't do much other than brush the evaporator, and it wasn't not that much came off. We have a really high temperature split. So I can scroll back and have a look right here. So we've got a low saturation temp, 32 degrees. This is a 410A system, I think. Yeah, it's a 410A. Let me just double check. I'm almost positive it's 410. What are we at right here? 410A. Yeah, we're a 410A system. So this thing has a bunch of issues. We're running a really low load. We're going to start frosting back in a minute because there's like no load. But first off, let's check our liquid filter dryer to see if we have a temperature drop. So 106 on one side. 107 on the other 106. So we have no temperature drop across the dryer. So there's nothing going on there. Subcooling, give it a second. We've got about 5 degrees subcooling, about 4 degrees superheat. This sensing bulb really needs to be insulated, and it's not super tight. We need to clean that evaporator. And I bet you anything, I'm gonna try to go downstairs, but they got a packed kitchen. I bet you they've got a return air issue too. I need to see if we can find that return air guy. I'm gonna go get some insulation tape. We'll try to tape this up real quick. According to the charging chart right here, for a 5-ton, 95-degree ambient, we're requiring 17 degrees of subcooling on this guy. So I'm gonna try adding a little bit of refrigerant. The superheat is doing a lot better now that we insulated that sensing bulb. It's still kind of bouncing around, but let's go ahead and add a little refrigerant. See if we can get that subcooling higher, see if we can get a few things to stabilize out on this guy. Before I go adding some refrigerant to this guy, we need to look into the airflow, because Measure Quick can sometimes be wrong about the airflow, but it keeps getting lower and lower. It's saying 500 CFMs, 600 CFMs, and my temperature split's huge. Earlier too, I said I had no load. No, I have a load. It's like 80 degrees in that kitchen, 77 degrees. But I'm wondering, I pulled this off just to see if there was a huge suction, and there's not. So I wonder if it's just a dirty coil. So I'm gonna pull that apart again. We're gonna have a look at that evaporator coil, maybe get some cleaner on it. I think it might be damaged beyond repair because it was pretty beat up, but let's pull that off again and have a closer look. We know that it's gonna work now, but we just are not moving air through the coil properly. Boy, that evaporator is just trashed. I mean, it's definitely dirty in some spots, but it's just completely demolished. I'm gonna try to get some cleaner on there, but it's gonna be a pain because we don't want the water to get down into the duct. So that's gonna be a chore. Yeah, I don't know if this thing's gonna come very clean, but I have a hard bristle brush for the vacuum. Vacuumed all the crevices out, got the big stuff off. Now we're gonna get some of the Viper aerosol coil cleaner. We're gonna put it all over, front and back, on the inside and the outside. And then just make sure it drains and just go slow with this. And I got the vacuum here to suck up any water if it starts overflowing or anything. I'd say it's a little dirty. It's coming out nasty. And I'm vacuuming it up, but this aerosol coil cleaner works wonders. So far I've only used half a can. Let it sit. I scrubbed it with a steel bristle brush just to get the surface stuff, and then now we're just kind of slowly rinsing it, letting it drain, rinsing it, letting it drain. All right, we are back in and running, and let's have a look at my system vitals. Look at that saturation temperature. It's already much higher, so that's why it's so important, airflow before charge. Let's look at our airflow. Our temp split is 20 degrees, about 2,000 CFMs of airflow now. So now we're moving air. So we're gonna let it dry out all the coils, verify everything stays the same, and then we will dial in the charge a little bit better if need be. And I wanna clean this condenser too, because there's a bunch of gunk and stuff in there, but I gotta put all the panels back on. So we're gonna let it run for a bit longer. I ended up using the Viper coil cleaner. Ended up just taking 1 can for the whole evaporator, front and back. I sprayed front and back, rinsed it a bunch of times, made sure it drained, cleared all the dirt. All that dirt came out of it. It's still really messed up, but it's a little bit better than it was. This is a small enough AC that I'm not gonna mix chemical. I'm just using another can of the aerosol cleaner. And what I find is when you go up and down like that, it tends to get inside of there. The water is pretty much coming through the inside from the outside. So I don't think I need to take the top off the unit. It's not that dirty. Really, the dirtiest part was just up here in this top where I'm spraying right now, because the people have been cleaning the coil and just not getting to that top section back up in there, like way up in there. So I'm just putting some chemical on here. We'll clean this whole thing, and then after that we'll check the charge, but we got to let the coil get dry before we check the charge. So we'll get this fired up here in just a minute once I rinse it all off. So this cleaner that I'm using, the aerosol cleaner, I'm just topping off this can right now. This is evaporator or condenser coil. If used on an evaporator, it's technically a non-rinse cleaner. It's made by Refrigeration Technologies. It's the same thing as their yellow Venom pack. It's just in an aerosol form. So good stuff, very safe, microchannel safe, all that good stuff. So it's just a solid quality detergent based cleaner. All right, I took the panel off and it is kind of dripping in there, but you want to be careful about taking those off when it's still wet, because that's why I put them all back on, because it just drips down. But that's the compressor, so it's fine. My probes can get a little wet, no big deal. The unit's all rinsed and cleaned. We need to let it dry out. So if we look, okay, first and foremost, everybody's asking me, this is a case made by a company called Rockform. They make a magnetic iPad case that has a cover, but it won't go for the newest iPad yet. It only goes for the last year's generation and before. It's an iPad Pro. But anyways, regardless, we're back on here. We need to wait for this thing to dry out. A real good indicator of whether or not it's dry is look at our liquid line temperature, 78 degrees. Look at our outdoor air temperature, 97 degrees. That liquid line temperature has to be higher than the outdoor air temperature. So we need to just let it run for a bit and kind of stabilize out. And then once we do that, then we'll potentially add refrigerant if need be. Once everything dries off. It's drying off pretty good, and it's actually looking pretty good. We've got about 15 degrees subcooling almost at the moment. We're calling for about 17. 99 degree liquid line, 93 degree outdoor air temp. So we might put a little bit of gas in there, but it's really not that bad. Let's see. Airflow's a hair on the low side, but it's slowly loading up. Temp split, a little bit high, so we're going to let it run a little bit longer just to kind of stabilize out, just to make sure there's nothing else funky going on here, but I don't think there is. 76 degree return, 50 degree supply. Looking pretty darn good. All right, temp split's about 26 degrees. It's not going to get too much better than that. It's a little bit high, which I don't doubt there's ductwork problems. Subcooling's about 15 to 16 degrees. It's kind of moving as the superheat moves, so this valve is trying to find its happy place. Every once in a while you'll see it open up, subcooling will drop, but overall this unit is kicking butt. It's doing a whole lot of work that it wasn't doing before we got here. We had a messed up wire on the run capacitor for the condenser fan motor that was not feeding the third leg of power to the compressor, because Carrier uses single pole or two pole contactors. It was causing the compressor to single phase. We repaired that, got the condenser fan motor running, cleaned the evaporator, cleaned the condenser. This unit's got a new lease on life for what it is. It's polishing a turd, but yeah, they're gonna be happy. Let's have one more look in here. You can see it's kind of bouncing around right now as everything kind of stabilizes out, but I'm not going to put any more gas in there. I put a little bit in there. The last thing we're going to do is change those high flow Schraders that were leaking. So we'll take all of our gauges off and I'll change those really quick before I leave. All right, so these high flow Schraders, they're called Cormax fittings, made by a company JB. There's a special tool. Well, the tool I think is made by another company. Fast Test. I don't know if JB bought them or what, but regardless, to change these, what you need to do is loosen it just slightly. It's not the right size. Let me get the right size. There we go. All right, so all that we're gonna do is hold that, hold that. There we go. So you just crack it, then you put the tool on, pull that out, make sure it's in, nice and good. Whoops, you gotta make sure it grabs. There we go, now we're grabbed. Okay, so what we're gonna do is push this guy up, make sure it's on. And it's not the easiest thing, not the greatest tool. They need a pressure relief on it because you blow the gasket. It's kind of silly, but regardless, it works. So we're twisting the fitting off under pressure right now. When it starts clicking, it should be loose. Ball valve it off. Careful because it's under heavy pressure. There we go. There's the fitting. It's kind of sketchy when you do this, so keep that in mind. I like to put a little nylog on the O-ring, and I'll nylog on the threads just a little bit. There we go. Okay. And then we're just twisting it in now. And then once it's tight, then we'll tighten it with the wrenches, just like that. Okay, it's in. Close that. I hate that because it pops the O-ring out. Okay, slowly crack this valve. We're good. We're good. This guy's on. Now all we need to do is tighten it, torque it down. Now they make a special tool for that too, but you can handle that with your hands. All right, so we got a new high flow Schrader. Now I got to try to do the other one. I'll save you guys the agony of that. All right, we are back up and running. Both of the high flow Schraders have been replaced. Good to go. Compressor's nice and happy. We'll tell them to keep an eye on it. That single phasing compressor wasn't a good thing, but this unit's got a new lease on life for now until the next time it breaks.
You see that, you know, going through this, when I film these videos, it's not a planned thing, right? You're literally just hearing the way that my brain works, okay? And you can see that I too jump to conclusions at times. And, you know, initially I was thinking the system was low on refrigerant, and inevitably it ended up being a little low on refrigerant. But before I put refrigerant into it, I needed to address an airflow problem. Okay. But you can see that my mind jumps to like, hey, let's go ahead and add some refrigerant to it. Wait a minute. No. And then I said, you know, wait, we got to remember, let's fix the airflow first, airflow before charge, you know, and it's important to remember that. And it's also important to understand that I'm human. I'm a normal person. Okay. I'm not some robot that knows how to immediately fix everything. I don't. Okay. When you guys see things, if you find value in something that I say in my video, it could be something that was incorrect or something that was correct. Maybe you learn from it, or maybe you learn a trick to make it work better for you, right? If you learn value, just understand that majority of the time, the value that you're learning, if it's something good, is from a mistake that I've made previously in my career and that I've learned from, okay? I am human just like you. We all make mistakes. In my opinion, it's how we come back from those mistakes, how we grow from those mistakes. If you keep making the same mistake over and over and over and over again, clearly there's something in you that needs to change, right? But if you make a mistake once or twice and you learn from it, and then you don't make it anymore, I see that as a good thing, right? And you grow from it, right? So this one, again, from experience, right? Right off the bat, before I applied service gauges to it, I was like, hey, we need to leak check these high flow Schrader ports, okay? And so I did that, and I found refrigerant leaks. And then, and again, that's just from experience of fixing a system, finding out it's low on refrigerant, putting refrigerant in it, and then I couldn't find a leak, you know? And then later on, you find out, oh, it's the Schraders, you know, the high flow Schrader cores. They're different from a normal Schrader core. By the way, yes, the tools are expensive. I get it, okay? I subsidize the tool when I sell the fittings. There's an extra cost added to each fitting that helps me to subsidize the tool. So basically, you know, I add a couple extra dollars to each fitting, so that way it helps to pay for the tool. Okay. And then, you know, that tool's since been paid off by now. I've had it for a couple of years, and that's how I choose to do things. But if you're interested in getting that Cormax fitting removal tool, it's from JB Industries. You can find it at your local supply houses, but you can also find it at TrueTechTools.com. If you just look up Cormax on TrueTechTools.com, it'll come up. It's an expensive tool. It's $800. Okay, there's no ifs, ands, or buts. It's ridiculously expensive, a bit overpriced, to be honest with you. But that's JB doing that. Okay, but it's a necessary tool. There's a lot of Cormax fittings out there, and I don't mind paying money for a tool. So if you're interested in getting the tool, go to TrueTechTools.com, use my offer code BIGPICTURE, one word, at checkout. You can get a discount on most of the items on their website, and then I get a small commission from that. So that's a great way to help support the channel too. But to go back, you know, tools are expensive, and as long as I can see value in that tool, I don't mind for the most part. You know, you got to think about it. You got to do some math, but I don't mind spending money on tools if they benefit me. You know, I drug my butt for years on getting a press tool. Okay. It just didn't seem like something that was valuable to me. Right. And then I ended up getting one, and it's like, wow, this thing actually is really valuable. You know, I don't use press fittings for everything, but I do use it for refrigeration and for water and drain lines. You know, I'm not going to stop brazing on my refrigeration line sets. I'm just going to use the press tool when it's necessary, when I think there's value in using the press tool. But I definitely use the press tool on a lot of plumbing when I'm doing ice machine pipe jobs and stuff, because I do majority of my stuff in copper. If I'm doing the drains on the Manitowoc ice machines, I do a lot of those. I'll use the press tool. It makes my job go faster. So it took me a long time to justify the price. Once I did it, I realized, man, this was a really smart decision, you know, but I dropped probably $3,000 or $4,000 into the press tools, you know, and all the jaws, and because you got to have different jaws for water, different jaws for refrigeration, like all this different stuff. I dropped a bunch of money on that stuff, but in the long run, it makes you money, right? If it makes your job go faster and it works good, then go for it. Same thing with that Cormax tool. Yeah, it's ridiculously expensive. Yeah, it's hard to stomach, right? But I do it. Now, another important thing to understand is that I buy tools like that Cormax fitting, right, for my employees, but some companies don't, and the employees are left to buy their own tools, and I get it. It's a hard thing to stomach if you're not able to subsidize the price of that tool in the fittings. If you're buying that for yourself and your company's not buying it for you, I totally understand why you wouldn't want to buy it. I get it. Because if it's not going to do much for you, you're not making any extra money from it, why buy a tool like that, right? So again, running the business, it's easier for me because, you know, I buy those tools, right? Now, I don't have more than one of those. I have one of those at my company. We're a very small company, okay? We only have 3 service techs out in the field doing service calls every day. So we have one tool and we let it float between us. It's currently sitting in my van right now, but if someone needs it, they just tell me and then they'll take it and use it for what they need to use it for, okay? So, you know, it's just one of those things. You do you. But if you guys are interested in purchasing one, if your company's interested in purchasing one, go to TrueTechTools.com. Use my offer code Big Picture again. I'll get a small commission. You get a discount. Great way to help support the channel. Now, when it comes to, you know, this unit, it's an old unit. The customer needs to replace it, okay? I'm sure I'm going to get a lot of comments like, why even fix it? Just tell them to buy a new one or just sell them a new one. In the commercial world, you have to get equipment up and running. They need it, okay? Yeah, inevitably, they should replace this. In the long run, it'd be a smart decision. But in the short term, they need an air conditioner that's working. And even if they got to drop a couple grand to get it working, it's still of value to them, because if they have cooks in the kitchen that are dying because, you know, one of the 3 kitchen ACs isn't working, you know, that's a problem, because then the cooks get upset. They might quit. They might, you know, who knows? Just that kind of stuff, right? So these customers, they got to get this equipment up and running. They will oftentimes choose to put up to a couple grand into it just to get it going. And I've been doing that a lot this summer on a lot of my equipment. You know, changing compressors, repairing, putting thousands and thousands of dollars in equipment because the customers ordered new equipment, but it's going to take till the end of the year to get the new equipment, you know, so they got to do what they got to do to get it going. I really appreciate you guys making it to the end. Again, if you haven't already, please consider subscribing to my YouTube channel, hvacrvideos.com. If you have any feedback, leave it down in the YouTube comments, or you can shoot me an email, hvacrvideos@gmail.com. Did I don't know if I said my website wrong. Anyways, whatever. Oh, no, I said subscribe to the YouTube channel. Yeah, I'm sitting here thinking I don't know. I may have mismatched my words there, but you guys get the point. But yeah, subscribe to the channel. Check out my website, hvacrvideos.com. We have merchandise available on there. That's a great way to support the channel. But you know, the easiest way to support this channel is literally just watch these videos from beginning to end. That really is the easiest way. You can also support it via PayPal, Patreon, or YouTube channel memberships. There's links in the show notes for each one of those methods. Last but not least, TrueTechTools.com, which I mentioned earlier. You can use my affiliate code at checkout, Big Picture, one word. You get an 8% discount on most of the items on their website. I get a small commission. Again, another great way. Thank you so very much. I really do appreciate you, and we will catch you on the next one.